The next thing we're going to do is we're going to expand this a little bit, and we're going to ask, what do we do when we have two inequalities? Well, when we have two inequalities, what we do is we split the problem up into two subproblems. Then we're going to solve each of the subproblems individually, and finally we'll take the intersection of the two subproblems. So I'm going to draw a line down the middle to split it up into two problems. So I have 3 less than x squared minus 1, and x squared minus 1 is less than or equal to 8. And both of these problems I'm going to solve individually. Then, after I've done this, I'm going to intersect the two solutions. So here we have that x squared minus 1 minus 3 is greater than or equal to 3 minus 3, or x squared minus 4 is greater than 0. Well, this simplifies to x minus 2, x plus 2, when we factor, being greater than or equal to 0. My split points are x equaling 2 and minus 2. Minus 2, 2, drawing the sign chart, gives x minus 2, x plus 2, gives positive, negative, negative, positive, positive, negative, multiplying positive, negative, positive, and here we're at 0 for these two split points, so it's at 0. My bound is a strict bound, and I want to include everything greater than or equal. So I'm going to include this point and above, and I'm going to include this point and below. So x is in the interval minus infinity to minus 2, union with 2 to infinity. And now we have the next condition, which is that x squared minus 1 minus 8 is less than or equal to 8 minus 8. Or x squared minus 9 is less than or equal to 0. Now we factor this. X minus 3, x plus 3 is less than or equal to 0. And our split points are x equals minus 3 and 3. Again, I'm going to draw a sign chart about the points minus 3 and 3. And our factors are x minus 3, x plus 3. Completing the sign chart, we get positive, negative, negative, positive, positive, negative. Doing the multiplication, positive, negative, positive, and we're indicating that we're equal to 0 at these points. Now, we want less than or equal to 0 here. So we're going to take negative and 0, meaning that x is in minus 3 to 3. To intersect these two intervals, I'm going to draw 3 number lines. The first 2 number lines, I'm going to draw my 2 constraints. This is minus 2, and then minus 3 to 3. And now I'm going to intersect them. And I'm going to take the key points of all my lines, wherever it goes from being there to not being there. And I'm going to take everything that is in both of these lines, or in all of these lines. So minus 3 is in both lines up until minus 2. After which, it's not in both lines. And then when I get to 2, this is 2, not negative 2. All of a sudden, I'm again in both lines, and up to 3. Once I pass 3, I'm no longer in both lines, but at 3 I am. So now I represent this using my intervals with a union of disjoint intervals. Nice. So now I have another multiple inequalities. And the weird thing here is that I've expressed this in a slightly interesting notation. I've expressed this saying that 3x minus 2 is less than 4, and 3x minus 2 is less than or equal to 2x minus 1. But the 4 and the 2x minus 1 aren't related to each other, which can get people a little confused. Another way to write this, which is a little bit more easy to read, is 4 is greater than 3x minus 2, and 2x minus 1 is greater than or equal to 3x minus 2, which is exactly what we do. We break it up into two problems, and we're going to take the intersection of these two problems. So once again, we divide it down the middle. And on the left-hand side, we have 4 greater than 3x minus 2. The right-hand side, we have 3x minus 2 is less than or equal to 2x minus 1. Now here we have 0 is greater than 3x minus 6, or 0 is greater than 3x minus 2. Whereas here we have 3x minus 2x is less than or equal to minus 1 plus 2, or x is less than or equal to 1. Now here, this is a very tempting way to do it, but I'm going to do it slightly different. I'm going to 4 is greater than 3x minus 2, and 3x minus 2 is less than or equal to 2x minus 1. And here, we could just simply isolate for x. So 6 is greater than 3x, or 2 is greater than x. And here, x is 3x minus 2x is less than or equal to 2 minus 1, or x is less than or equal to 1. And now we could take these and intersect them. But that goes away from our split point technique. This does work, but it works just because this is nice. So I really encourage you, if you're trying to get the hang of solving inequalities, just stick with the split point technique, because it always works. It will always work. It might take a little bit longer, but it will always work. So 4 greater than 3x minus 2, and 3x minus 2 less than or equal to 2x minus 1. Here we're going to get everything to one side. So 0 greater than 3x minus 6. Factor 0 greater than 3x minus 2. And our split point is going to be x equaling 2. Drawing my sign chart, 2, and I have the factors 3 and x minus 2. Solving the signs, positive, 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 negative. I'm going to be positive, negative. At 2, I am 0. 0, I want to be strictly less than. My goal is my expression is less than. So I'm going to be not at 2 and everything less, which tells me that x is less than 2. Over here, get everything to one side. So I'm going to get 3x minus 2x minus 2 plus 1 is less than or equal to 0, or x plus minus 1 is less than or equal to 0. My split point is x equaling 1. Notice it's already factored. So 1 goes here, x minus 1. Creating my sign chart, I am 0 at x minus 1. I am going to be positive here, negative here, positive, 0, negative, and I want to be less than or equal to this value. So here, less than or equal, I'm going to be taking here and below. So this gives me that x is in the interval minus infinity up until 1. And here, x is in the interval minus infinity 2. And I include 1 here. I do not include 2 here. Now, if I take the intersection, I got the line up to and including 1, and the line up to but not including 2. Intersecting these gives me 1 and below, or x is in minus infinity up until 1. I encourage you to practice the following exercises. Try to satisfy these two equalities.